Okay, this is a very quick demo of Arlon building a cluster and managing applications and the entire cluster out of Git. But I'm going to start this demo with the end product, and we're going to work backwards through to how we got there. So right now I'm looking at Redis. It is a pod running on this cluster called EKS-C-Jones2. This cluster is actually being completely built using Arlon, running an EKS. And after it started up, Arlon leveraged a profile to then go through and install Redis, the number of other applications. Coming back here, I can see there's some failed deployments. That's not actually on the cluster I want, so I'm just going to change to EKS2 and expand this out to say 50. And I can see I have Elastic running, I have Redis running, I have Zookeeper running, I have the Kibana dashboard and the Elastic cluster also running. And as I said before, this is all running on a cluster in EKS that was built by Arlon. This data is all available within Platform 9 as I actually imported this cluster and importantly installed the Echo agent, which creates a secure communication tunnel from within that cluster. So that's the cluster running, built by Arlon with a profile automatically deployed. What does this look like if we were to take the Argo CD view of that? Well, this is the external cluster operator. So this is what was connecting that cluster into Platform 9. If I come back to applications here, though, we're going to see a number of different elements or Argo applications that are running, that were installed and created and are managed by Arlon from Git. The first piece here is EKS-C-Jones. This is the actual Kubernetes cluster, built leveraging 100% upstream cluster API and standard cluster API YAML files, all created automatically into Git by Arlon, and then importantly by Arlon into the Argo CD application running on our management cluster. As part of that deployment, there's also a profile that gets deployed. That profile is down here, EKS-C-Jones profile platform apps. Inside of here, if I just zoom in and make it a bit bigger, you're going to see that Elastic, Kafka, Redis, and Zookeeper are all specified as applications. What that causes is the deployment of each of these applications independently onto the cluster, and as we just saw from the Platform 9 UI. So the question is how are we pulling all of this together? This is getting created from applications stored in Git and, importantly, a cluster specification, as we call them, of the shape of the cluster. And Arlon is bringing both of these pieces together and orchestrating the cluster creation between Argo CD, cluster API, and then importantly, automatically registering the cluster that was created in cluster API into Argo. So then Argo can go forth and deploy all the applications that were put into our profile. So I'm going to do this from scratch onto this cluster, but for time savings, I'm not actually going to build a new cluster. I'm just going to update the app that it's running. So I'm going to go through and make a series of new bundles. These bundles are pointers to applications in Git. And when I create them using Arlon, what it's going to do is make a reference or essentially a pointer in Arlon to that app. So that's Zookeeper, bundle getting created. And just remember, bundle is just an app stored in Git. Elastic. This one's Kafka. This one's Redis. These are all just in the Platform 9 community Arlon demo apps directory. And I've provided the path through to each one of these apps if I come back here to the top level. So Each of those bundles I just created point to these directories. The next step is to say, those apps are actually going to be in a new profile that I want to call my base infrastructure apps. I'm going to store them in my workspace repository. So this can be a separate repository. In my example, this is a separate repository. I'm just going to copy this, and it points to all of the bundles. And importantly, these names all match up to the bundles I just created. If they don't, obviously it's going to fail to work. So I'm going to take that command and create a new profile. That's going to take a bit. So now I can say Arlon profile list, and it's going to give me a list of profiles. A little bit hard to read here, but you see base infrastructure apps is here at the top. I can also say Arlon bundle list. It's going to list all my bundles. I've got a few more of those, but you can see here the platform 9 community apps.git. So pointing to that. And importantly, the path /apps/Kafka and apps/Redis through to where that app is actually running. So the next step is to say, I want to apply that to a cluster, and I'm going to apply that to a cluster that's running. To do this, I am going to run Arlon cluster update, the cluster name, and the new profile. So it's currently running platform apps. I'm going to change this to base infrastructure apps. I'm going to copy that, come back to my command line, press enter, and off it's going. If we come back here and watch this happen, we're going to see this profile platform apps. It's going to update, it's going to change, and Arlon's driving all of that change, and importantly, driving all of it from what is stored in Git. So we're getting closer to that GitOps operation. Just going to hit refresh. Sometimes I feel impatient. Here we go. That synchronization happened. That took a bit of time because I don't have a webhook set up that's going to push that change. If I had set up a webhook between the repositories, I would have seen that change happen automatically. So this is now updating and deploying everything that was in that profile. Obvious to point out here, it's deploying apps that were already deployed. This could, of course, cause a problem. What you can see here, though, is the apps that were in the previous profile are now in a state of deleting. So Arlon's keeping all of that in sync and making sure that only the application and only the profiles that you've specified on that cluster are up and running. This is going to take a bit of time, so I'm going to touch on the last piece of Arlon that you use to create clusters, and that is the cluster spec. So if I clear up my terminal here, Arlon cluster spec list, you can see that I've got one, that's a cluster API EKS on 1.21. So the naming convention I've been using. It's using cluster API. The cloud provider is AWS. The type is EKS because, of course, it could be a non-EKS cluster. Important, a Kubernetes version that EKS supports. And then, node type, node count, and SSH key it's using, and then any tags that are going on. That all comes together into a single command to build a cluster. When you build a cluster using Arlon, you're specifying the cluster spec and the profile itself. Well, bring up help, see the list of commands. Ooh. And here you can see, so I can go Arlon, cluster, deploy. And then if I was going to build a new cluster, I would be providing a cluster name, the cluster spec, and the profile, as well as the URL for where that cluster is going to be storing all of the objects to be managed out of a Git repository. And there you have it. That's defining a cluster spec to act as the shape of your cluster, defining bundles of applications or objects that are stored in the Git repository that then get pulled together as a profile. And then by using Arlon, it will go and create the cluster via cluster API via Argo CD. Once that cluster starts, Arlon then automatically registers it into Argo CD and then continues to deploy the profile, which is made up of all of the individual bundles or applications that they're pointing to, and deploys all of them down into your cluster. And from start to finish, you have a complete cluster with all the applications that you want running. And of course, if you're using Platform 9 and it's an EKS cluster, you can very easily come in and say, hey, I'm just going to import that cluster, go through that process, and then install Echo. So you get a connected status here and start working with those workloads and looking at what's going on. Thank you very much for the time. That's a brief introduction to Arlon, Argo CD, and Cluster API all working together to build clusters at scale.